Welcome to another deep dive. This time, we'll be exploring the life and work of Johannes Kepler.
This should be exciting.
Definitely. You know, when I think of Kepler, I always picture those perfectly nested platonic solids. And,
Oh yeah, his model of the solar system.
yeah, it's just such a striking image, those geometric shapes dictating the cosmic order. But before we dive into that, let's start at the beginning.
Right, with his biography.
Exactly. We've got excerpts from the McTutor History of Mathematics archive, which seems to cover pretty much everything. So we should be able to get a good grasp of not just what Kepler discovered, but also his motivations and the context of his work.
I think a good place to start is with his background. He wasn't exactly born into a life of scholarship, was he?
Yeah, the bio says he was born in a small town in Germany. His father was a mercenary soldier, and his mother was an innkeeper's daughter.
Now, the typical path to becoming one of history's most famous astronomers.
Definitely not. He even spent some time helping out at his grandfather's inn.
Imagine a young Kepler practicing his math skills by keeping track of tabs and calculating tips.
That would be a sight to see. But what really fascinates me is that even with this humble beginning, Kepler was deeply religious. He saw understanding the universe as a way to understand God's creation, like it was all part of this grand mathematical plan.
That's right, and this belief definitely fueled his passion for the Copernican system, placing the sun at the center of the universe instead of the Earth.
Which, at the time, was a pretty radical idea.
Oh, absolutely. Going against the established geocentric view was a big deal.
And, it's kind of ironic, but despite his strong religious beliefs, Kepler ended up being excommunicated later in life. Some of his ideas didn't quite align with the strict Lutheran doctrine.
Yeah, that must have been devastating for him, considering he saw his work as part of his faith.
It really shows the tension between faith and scientific inquiry during that time.
For sure. But even with those challenges, Kepler was always searching for answers. His first major work, Mysterium Cosmographicum, really exemplifies that.
Yeah, in that book, he tries to answer the question of why there are 6 planets, as they knew it then, in the Copernican system, and why they are spaced the way they are.
Such a fundamental question.
And his solution, well, he uses the 5 platonic solids to explain it all.
Ah, yes, the perfectly symmetrical 3D shapes, the tetrahedron, cube, octahedron, dodecahedron, and icosahedron.
You know them by heart. But seriously, it's like he envisioned these shapes as the scaffolding for the universe, with the spheres representing the planets' orbits nestled within and around them.
It's a pretty wild idea when you think about it.
Totally out there. But what's even more surprising is that his model was surprisingly accurate. Less than 10% error in predicting the planet's distances from the sun.
Which is pretty impressive for the time. And he uses accuracy as evidence to support the Copernican theory.
Talk about a bold move. But he didn't stop there, did he? He sent his work to Tycho Brahe, who was like the observational astronomer of the day.
The rock star of astronomy, with his huge collection of precise planetary observations.
Yeah. So it seems like Kepler wasn't satisfied with just having an interesting idea. He wanted solid data to back it up.
He was always pushing for more accuracy and a better understanding.
And that ambition eventually led him to work for Brahe, which turned out to be a pivotal moment in his career.
A major turning point. But we'll have to delve into that in the next part of our deep dive.
Right. We'll pick up the story next time with Kepler facing his war with Mars.
Yeah.
Stay tuned. So last time, we left off with Kepler teaming up with Tycho Brahe, and he was about to embark on this war with Mars.
Ah, yes.
What made Mars's orbit such a challenge for astronomers?
Well, before Kepler, the assumption was that planets moved in perfect circles.
Right. Circles, perfect circles.
It just made sense, Circles were considered the most perfect and harmonious shape.
Yeah.
But Mars wasn't exactly cooperating with that idea.
Yeah, I guess not.
Brahe's observations of Mars, they were so precise, and they just didn't fit that circular orbit model.
So Kepler had to kind of throw out centuries of tradition and start fresh?
Pretty much, yeah. It was a radical move for the time. He spent years, literally years, poring over Brahe's observations, making endless calculations, trying to reconcile the data with the existing theories.
I see.
It was a real struggle, hence the name war.
Yeah, that makes sense. But all that work, it paid off, right? Because he finally figured out that Mars's orbit wasn't a circle at all.
Right. It was an ellipse.
An ellipse. That's Kepler's first law.
Exactly. That's the one. It was a revolutionary discovery. Planets don't move in perfect circles around the sun, but in ellipses, with the sun at one of the focal points.
Okay, so not a circle, but an ellipse.
And that finally explained why Mars's orbit seemed so off.
But didn't he also discover that a planet's speed changes depending on where it is in its orbit?
You're thinking of Kepler's second law.
Okay.
He discovered that a line joining a planet and the sun sweeps out equal areas in equal times, meaning a planet moves faster when it's closer to the sun
Okay.
and slower when it's farther away.
I see. So it's not just the shape of the orbit, but also the way the planet moves within that orbit.
Exactly. Both groundbreaking discoveries.
Yeah.
And, both of these laws show just how important Kepler's Copernican viewpoint was. Placing the sun at the center,
Right.
he was able to see the patterns and relationships that had been hidden for centuries.
That's fascinating. So it was really a shift in perspective that allowed him to make these discoveries.
I think so, yeah. Sometimes you need to look at things from a completely different angle to see what's really going on.
I like that. But it wasn't just about coming up with these laws, was it? I mean, Kepler was also really focused on making sure his theories matched up with the actual observations.
Oh, absolutely. He was incredibly rigorous. One of the first to explicitly acknowledge the concept of observational error.
Observational error.
Yeah. He knew that measurements weren't perfect.
Right.
There was always a degree of uncertainty.
I see. It's like acknowledging that you can't know everything for sure, but you try to get as close to the truth as possible.
Exactly. And this meticulous approach, it's evident in all of his work, not just astronomy, optics as well.
Right. I remember reading about that. He developed the first correct mathematical theory of the camera obscura.
It's like a pinhole camera.
Right. And he even figured out how the human eye works, with the image forming upside down on the retina.
It's amazing, isn't it?
Yeah. I mean, he was exploring all these different areas.
He was a true polymath.
Yeah. Constantly curious, always trying to connect the dots between different fields of knowledge.
And let's not forget about the supernova that appeared in 1604, what we now call Kepler's supernova.
Right. He studied that too, right? Very meticulously. Didn't he reject a lot of the explanations for it?
He did. He insisted on exhausting all the natural possibilities before resorting to, supernatural ones. It's a great example of his scientific mindset. Skeptical, methodical,
Right.
always seeking a logical explanation based on evidence.
Makes sense. But not everything in Kepler's life was about scientific breakthroughs.
No, unfortunately not. He faced some pretty significant personal challenges.
Like what?
Well, he lost his son and his first wife.
Oh, wow. That's awful.
And on top of that, he was excommunicated from the church.
Oh, right. We talked about that.
Yeah.
It's remarkable that he was able to continue his scientific work with all of that happening.
It really is. He did eventually remarry, mainly out of necessity, though.
A necessity.
Yeah. He needed someone to help care for his children.
Oh, I see.
And his second wedding, believe it or not, actually sparked another scientific inquiry.
Wait, really? What happened?
He became fascinated by the way they were measuring wine barrels at the wedding feast.
At his wedding?
Yeah. They were using a rod slipped diagonally through the bunghole.
Okay.
And Kepler started thinking about whether there was a more accurate way to calculate the volume.
He was thinking about math problems at his own wedding.
Apparently.
That's incredible.
It is. And you know what? It led him to study the volumes of solids of revolution, which resulted in his book Novus Stereometria Doliorum.
Right. Introducing some pretty groundbreaking mathematical ideas.
Wow. So from planetary orbits to wine barrels, Kepler was finding inspiration everywhere.
He seems to have been. He was always searching for that deeper meaning, those connections.
Yeah. And speaking of connections, didn't he have this lifelong interest in finding harmony in the universe?
Oh, he did. He was convinced there was an underlying mathematical order to the cosmos, a kind of music of the spheres governing the movements of the planets. An idea that had been around since the ancient Greeks, but Kepler wanted to find the actual mathematical relationships.
And that led to his book, Harmonices Mundi. Right?
Yes, where he laid out his vision of this beautifully organized universe.
And within that work, he made yet another incredible discovery, Kepler's third law.
Right. It's a bit more complex than the first two, but it essentially states that the ratio of the squares of the periods of any two planets is equal to the ratio of the cubes of their average distances from the sun.
Right. That sounds complicated. A mouthful, I know. But basically, it's a mathematical relationship that describes how the time it takes a planet to orbit the sun is related to its distance from the sun.
Oh, okay. So the farther away a planet is, the longer it takes to orbit the sun.
Right. And the relationship between those two is very specific, and that's what the third law describes.
I see. And did he just, easily discover this?
Well, what's interesting is that he actually stumbled upon this law while the book was already in press.
Oh, wow.
He had to make last-minute revisions driven by this, eureka moment.
I can imagine that was exciting, but also kind of stressful.
It must have been, but it shows how he was always pushing the boundaries, even when he thought he had things figured out.
Always thinking.
Yeah.
Always making those connections. But, we mentioned his personal challenges earlier, and one thing that always stands out to me is that he had to defend his own mother from accusations of witchcraft.
Yeah, that must have been incredibly difficult.
I mean, can you imagine dealing with something like that while also trying to revolutionize astronomy?
It speaks volumes about his resilience. The emotional toll must have been immense.
I wonder if those challenges fueled his determination even more.
It's possible, and even amidst all that, he was still focused on his work. He was studying music theory while he was traveling to defend his mother,
Wow.
and even integrated some of those ideas into Harmonices Mundi.
It's like his mind never stopped working.
And he was a big proponent of logarithms.
Logarithm.
Yeah. He even published a proof demonstrating how they worked, because there was some skepticism about them at the time.
It's like he was always looking for the most efficient, elegant way to explain things, whether it was the movement of planets or the principles of mathematics. But what about his Rudolphine tables? Weren't those a big deal?
Oh, they were a major accomplishment. These were astronomical tables based on Brahe's observations
Right.
and Kepler's own laws of planetary motion. They were incredibly accurate and remained so for decades,
I see.
really solidifying the validity of his work and the heliocentric model.
Okay, so like the culmination of all his work.
In a way, yes, a testament to his precision and dedication.
But we can't talk about Kepler without mentioning his relationship with astrology.
Right. It's a topic that often comes up.
Okay, I mean, he did provide astrological advice.
He did. But his approach was much more nuanced. He wasn't just predicting people's futures based on their star signs or anything like that.
Yeah.
He believed that celestial bodies could influence earthly events, but he rejected the idea of precise predictions.
Mhm.
He was actually more focused on angular relationships between celestial bodies rather than traditional constellations.
I see. So it was a bit more mathematical.
Exactly. Less mystical, more grounded in observation and calculation. But we'll delve a bit more into that in the next part of our deep dive.
So we've covered a lot of ground in our deep dive into Kepler. His groundbreaking work in astronomy and mathematics, his struggles with religious authorities, even his foray into astrology.
It's really quite a remarkable life, isn't it?
Definitely. I mean, navigating all those different areas, challenging conventional wisdom.
Exactly. While at the same time grappling with the complexities of his era.
It's like he was standing at this crossroads, embracing observation, mathematics,
Right.
but still influenced by those older philosophical and religious ideas.
Absolutely. And his personal journey is just as fascinating as his intellectual one. I mean, born into those humble beginnings, he ends up working with the leading astronomers of his time.
Yeah, even advising emperors and military leaders.
Imagine that.
From a small town to the courts of kings. And even in his final days, he was still traveling, I think, to collect money owed to him.
I think you're right. For the Rudolphine tables, he died in Regensburg, far from where he started.
Yeah. It's a pretty incredible story when you think about it.
It is.
So what would you say is Kepler's most significant contribution to science?
Yeah.
I mean, how did he really change our understanding of the universe?
Well, I think he transformed astronomy from a purely descriptive practice to a physics-based one. He showed that the movements of planets could be explained by mathematical laws.
Right, not by like mystical forces or divine intervention.
Exactly. And his insistence on comparing his models with observations, his acknowledgement of observational error, his pursuit of that mathematical harmony,
Yeah.
these are all cornerstones of modern science.
It's amazing to think he figured all of this out without the tools and technology that we have today.
Yeah.
It was just like raw brain power and a lot of calculations.
It's mind-boggling.
It really is.
Yeah.
And, that fascination he had with finding harmony in the cosmos, it makes you wonder, could that same principle be applied to other areas, even today?
That's a fascinating thought.
Like, are there hidden patterns and relationships in other fields just waiting to be discovered?
Like Kepler did with the planets.
Exactly. I think his legacy goes beyond just his specific discoveries. It's an invitation to keep exploring and searching for those deeper meanings in the world.
Absolutely. And his story reminds us that even when facing hardships and uncertainty, the pursuit of knowledge can be a source of profound meaning, a real purpose.
So as we wrap up our deep dive into the life and work of Johannes Kepler,
A truly fascinating figure.
A true visionary who wasn't afraid to challenge the status quo, and whose insights continued to inspire us, even centuries later.
I completely agree, and I would encourage everyone listening to continue exploring. There's a whole universe of fascinating details and stories out there just waiting to be discovered.
Absolutely.